Hello children, welcome back to my channel. Now I am dealing with 8th class maths exercise playing with numbers exercise 15.4. This question is check whether 25110 is divisible by 45. According to the property that we have learned, let us write factors of 45. Factors of 45 is 1 into 45, then 3 into 15, and then 5, 6, 7, 8, 9. 9 5s are. So let us see. 25110 has 0 in units place. Therefore, it is divisible by 5. So this property it is accepted. Now 2 plus 5 plus 1 plus 1 plus 0 is equal to 7, 8, 9. 9 is divisible by 9. Therefore, 25110 is divisible by 5 and 9. Therefore, it is divisible by 45. We have learned now if a number is divisible by a number is divisible by any number, the number will be divisible by its factors. So here they have given you a number. This number is divisible by 45? They are asking. So what I did, I found out all the factors. In this, the last one I have taken 5 and 9. You can take anything, but it is convenient with this. So units place is 0, so it is divisible by 5. Sum of the numbers is 9, so it is divisible by 9. When it is able to divisible by 9 and 5, definitely it is divisible by 45. This is the answer, children. Please note it down. Now second sub, children. Check whether 61479 is divisible by 81, just like previous one. Take 81 factors. Factors of 81. Let us see. 1 into 81, 3 into 27, then it goes with 9. 9 9s are. So let us consider this. 6 plus 1 plus 4 plus 7 plus 9 is equal to 10, 18, 27. 27 is divisible by 9. Therefore, 61479 is divisible by 81. This is the answer, children, because both of them are 9 and 9. Once if you find out, it's enough. It is divisible by 9, so it is divisible by 81. This sum, children, check whether 864 is divisible by 36. Verify whether 864 is divisible by all the factors of 36. First, let me write factors of 36. 1 into 36, 2 into 18, 3 into 12, and 4 into 9, 6 into 6. So, 864 has 4 in units place. Therefore, it is divisible by 4 in its units place, so it is divisible by 2. 8 plus 6 plus 4 is equal to 18. The 18 18 is divisible by 3. Therefore, 864 is divisible by 3. So, 864 is divisible by 2 and 3. This implies 864 is divisible by 6. Therefore, 864 is divisible by 6. Therefore, 864 is divisible by 36. See children, last numbers I have taken. Divisibility property of 6 is the number should be divisible by what are the 2 and 3. So here in units place it has got 4. 4 is an even number, so it is divisible by 2. Sum of the numbers is 18, so it is divisible by 3. Since the number that is 864 is divisible by 3 and 2, we will say that it is divisible by 6. If it is divisible by 6, it is divisible by 36 because 6 6 are 36. So the first bit we have done. Second bit is verify whether it is divisible by all the factors of uh, 36. Of course, it is divisible. Verification means 4 and 9 if you take. First, let me take 4 and 9. Last two digits of 864 is 64. 64 is divisible by 4. And 8 plus 6 plus 4 is equal to 18. And 18 is divisible by 9. Therefore, what you can say, 864 is divisible by 9. So, this I have completed. And 3 and 12. 3 and 12. 8 plus 6 plus 4 is equal to 18. 18 is divisible by 3. Therefore, 864 is divisible by 3. Now, 12 means 12 is equal to 3 into 4. 864 is divisible by 3 and 4. Therefore, it is divisible by 12. Okay, even this I have completed. And 2 and 18. Let me do it here, children. 2 and 18. Already 2 I have done. It is divisible by 2. So I am not doing it. Let me talk about 18. 18 is nothing but 6 into 3. 864 is divisible by 2 and 3. We have proved. It is divisible by 2. I have proved it here. It is divisible by 3. I have proved it here. So already I have proved it is divisible by 6. So I need not write it, children. 6, 18 is divisible by 6 and 3. Let me write directly. 18 is divisible. Not 18. What is the number? 864. 864 is divisible by 6 and 3. Okay. Therefore, it is divisible by 18. Since it is divisible by 6 and 3, it is divisible by 18. And of course, 36. 36. Of course, 36. 864 is divisible by 860. 36 factors are 6 and 6, and 864 is divisible by 6. Therefore, 864 is divisible by 36. So each and every pair I have proved, children. They are asking to prove. Only the thing, you should know the properties. If you have numbers for 18, 12, you don't have divisibility property. For 36, you have no divisibility property. So once again, you have to make these numbers as factors, and that we have already proved it here. Basing on that, we can say that they are divisible. Please note it down. Check whether 756 is divisible by 42. Verify whether 756 is divisible by all the factors of 42. So let us write factors of 42. Factors of 42: 1 into 42, 2 into 21, 3 into 12, 3 into 14, and 4 it won't. 5, 6, 6 sevens are 42. Okay, that's all. So these are the factors. So let us see whether it is divisible by 6 and 7. So when you take 756 has 756 has 6 in units place. Therefore, it is divisible by 2. 7 plus 5 plus 6 is 18. 18 is divisible by 3. Since 756 is divisible by 2 and 3, we will say that 756 is divisible by 6. I have proved this. Now 7. 756 means in this 2a plus 3b plus c is equal to 2 into 7 plus 3 into 5 plus 6. 14 plus 15 plus 6 is 35. So what you can say? 35 is divisible by 35 is divisible by 7. Therefore, 756 is divisible by 7. So see, children, it is divisible by 6. I proved it is divisible by 7. So we will be saying that therefore 756 is divisible by 42. because we have proved that it is divisible by 6 as well as it is divisible by 7. So it is divisible by 42. The first part we have completed. Next, verify whether 756 is divisible by all the factors of 42. So the next factor, let me take 3 and 14. 756 is divisible by 3. We have proved it here. 14, we don't have any divisibility property. So take 14 as 2 into 7. And in that case, 756 is divisible by 2, which I have done it here. And 756 is divisible by 7, which I have done it here. Therefore, 756 is divisible by 14. So, these two, 3 and 14, I have proved. Now, 2 and 21. 2 and 21. 756 is divisible by 2. Already we have proved it here, divisible by 2. And 21 means its factors are 3 into 7. 756 is divisible by 3 and 7. We have proved. Divisible by 3 we have proved it here. Divisible by 7 we have proved it here. Therefore, 756 is divisible by 21. So it is divisible by 21 and 2 we have proved. And of course 42 we have already proved. Where we have proved it is divisible by 42. So this also we have proved. So with this, see children, this is the answer. Only the thing is you should know, you should remember the properties, divisibility properties of all the numbers which I have taught. I have taught 2, I have taught 3, I have taught 4, 5, 6, 7, 9, 11. These all I have taught. So basing on that property only we are doing. What is the other property that we have used here? A number will be divided by another number means A and B. If A is divisible by B, then A is divisible by all the factors of B. Basing on that, see, like 21, we don't have any divisibility rule. For 14, we don't have any divisibility rule. So, what we have taken? We have taken 21, and for 21, where is it 21? 21 is here. For 21, I have taken the factors of 21, and already we have proved, that is why I have written. If we could prove that it is divisible by the factors, then it is divisible by the number. Similarly, 14 also. The factors of 14 I have taken and I have proved. I hope I am clear, children. Please note it down. Fifth sum, children. Check whether 2156 is divisible by 11 and 7. 11 and 7. So let us take 2156. And for a divisibility property of 11, I am talking about 11. You have to say, take the sum of even powers and some even numbers and sum of even digits and sum of odd digits. So these are odd digits. 1 plus 6 is equal to 7 and 2 plus 5 is equal to 7. 7 minus 7 is 0. Therefore, 2156 is divisible by 11. Next, divisibility property for 7 we have to talk about. 2156. 2156 means For 4-digit numbers, whether it is divisible by 7 or not, you have got a property I have taught you earlier, children. 6 into A plus 2 into B plus 3 into C plus D. So 6 into A is 2 plus 2 into B is 1 plus 3 into C is 5 plus 6. 12 plus 2 plus 15 plus 6. So 2 to 4, 10, 15, 35. So we can say that 35 is divisible by 7. Therefore, 2156 is divisible by 7. See children, in the earlier case, 3 digits were there. 3 digits means 2a plus 3b plus c. Here 4 digits means a, b, c, d you will be getting. That means 6a plus 2b plus 3c plus d. This formula you use, you will be getting a number, and if that is divisible by 7, the whole number is divisible by 7. I have taught how divisibility property for 3-digit number, divisibility property for 2-digit number, 4-digit number, and also divisibility property for a big number. So please remember them, because usually children will forget about divisible property of 11 and 7. Don't forget them, children. So check whether this is divisible by 11 and 7. Therefore 2156 is divisible by 11 and 7. This we have proved. Verify that it is divisible by product of 11 and 7. 11 into 7 is 77. If, don't write if, since 2156 is divisible by 11 and 7, it is divisible by 77. Okay, so this is the answer, children. So the question is whether the given number is divisible by 11 and 7. For 11, what is the property I said? Odd place digits and even place digits. You have to separate them, you have to add them and subtract them. The subtracted one should be either 0 or 11 or multiples of 11. Here we got 0. So definitely it is divisible by 11. Next, 7 means it is 4-digit number. So the property is 6a plus 2b plus 3c plus d. The whatever value you are getting for that, it should be divisible by 7. So we have got it as 35. 35 is divisible by 7. So it is divisible by 7. 2156 is divisible by 7. So it is divisible by 11 into 11 and 7. Now they are asking the product of 11 and 7. Product of 11 and 7 is 77. Since 2156 is divisible by 11 and 7, it is also divisible by 77. Please note it down. The next question, check whether 1435 is divisible by 5 and 7. So let me talk about 5. 1435 has 5 in its units place. Therefore, 1435 is divisible by 5. And also we have to talk about 7. 5, 1, 4, 3, 5. So here 6a, 6 into a plus 2 into b plus 3 into C plus D. 6 into 1, 2 into 4, 3 into 3 plus 5. 6 plus 8 plus 9 plus 5. This is 11, 20, 28. 28 is divisible by 7. Therefore, 1435 is divisible by 7. So we have proved that it is divisible by 5 and 7. Now, whether it is divisible by the product of 5 and 7. 5 into 7 is equal to 35. Since 1435 is divisible by 5 and 7, it is divisible, it is divisible by 35. This is the proof for it, children, because the factors, it is divisible by the factors means it is divisible by its product also. So divisibility of 5, divisibility of 7, once again 4 digits, 6a plus 2b plus 3c plus d. So find out this, children. Please understand. I think I am clear. With this, I am completing my task today. In the next class, I will be doing next part.